system region through Verilog. I think there is one question in the Google sheet. So the name of this primitives is optional actually. So right, and we can give some name like G1, G2, G3. That is optional. That is why in some cases I think I didn't write that. If you have any more queries, you can ask.
Sir, how to do that the multiplication? Let's suppose we are doing multiplication for 5-bit and 6-bit. How to note
Okay.
the number of full adder used in that one and number of AND gate.
That you have to form the table. AND gates you can find out. AND gate is simply if you want to multiply 5-bit by 6-bit, 5 into 6, 30 AND gates are required. Because you will get 30 different product terms. And the number of full adders that depends upon the table. After forming the table only, we can find out how many full adders are required. AND gates is directly the number of bits of multiplicate into number of bits of multiply. Like 4-bit by 5-bit means 20 two input AND gates. But the full adders that you have to form the table. After forming the table only, we can find out how many full adders are required.
So forming the truth table.
Truth table actually it becomes very difficult if it is 5-bit by 4-bit or this one. So how many combinations you have to form? So a lot of combinations. So what you have to do is you have to form a table, multiplication table, which I have discussed in the lectures.
Yeah.
So from that you have to start from the LSB to MSB. So you have to add this. So we require full adders and half adders. So accordingly you have to give the connections.
Okay, sir. Thank you, sir.
Okay.
One more query, sir. You have told, sir, in the initial block.
Sorry?
In the initial block, if we assign, it will executed when the time equal to 0. Okay.
T is equal to 0. Yes.
Yeah. Suppose we have multiple assignment in there, means multiple. They are listed multiple variable in there in this in the assignment operator, and we also
all will be executed at the same time. T is equal to 0.
And no, means we give the time hash equal to 5.
If you give time using the hash symbol, then it will take the time. It will be delayed. Otherwise, all the initializations will be done simultaneously.
And it will be executed only once in the module.
Yeah. Because normally initialization will be at the start of this Verilog code.
Yeah.
So normally one time it will be execution of one time. That module is enough actually.
So we can say that we are writing initial for the test bench case.
Some initialization, say for example, if you want to have some feedback loop type of thing like flip flap. Flip flap actually the initial stage we don't know. So for that you can establish the initial stage. You can do in the initialization. The initial stage of this D flip flap is say Q is equal to 0 or Q is equal to 1. Because for the D flip flops, any sequential circuit, the output not only depends upon the present input but also on the previous output. So whatever the initial value, based on that, the present value will changes.
Okay. Sir.
Good afternoon, sir.
Yeah, good afternoon.
Sir, I have a doubt in lecture 6 video, sir. My doubt is,
Yeah, please.
yes, sir. In the for 4x3 multiplication,
Okay.
we have given the carry also as an input to the second RCA, sir.
Ah,
But instead we should give 0, sir. While explaining the theory, you explained that we are going to give another input as 0. But
so initial stage, the very first stage, it will be 0. After that, the carry will propagate.
yes, sir. But what about the C out of the first 4-bit RCA?
First 4-bit or that will be given as input for the next.
Sir, the code, everything is fine, sir. Then according to the question 4x3.
Actually, I don't actually exactly remember that lecture because I don't have that lecture. If you have that screenshot, you can share.
Sir, I too don't have right now, sir, but I remember having this doubt. I just felt that there'll be a small
If I
correction
see
needed.
the circuit, then only I can answer because no, I don't remember what circuit I have drawn there. So we can implement that 4-bit by 3-bit multiplier using many ways.
Yes, sir.
In offline also, you can send that screenshot of that one to my mail. Then I'll reply.
Okay, sir. Thank you, sir.
Sir, if you suppose we define a register of 4-bit
Yeah.
and an array of 64, means it will be a 1D array or a 2D array?
Please repeat the question.
Be write in the chat box, sir. Please see. Means I write the question in the chat box, sir. Please see.
Write in the chat box.
Yeah, I written, sir.
Okay. So register 03, memory 064. So what is your question?
Is a 1D array? Yeah, it is 2D array. Means in the computer.
See, actually, this will define 4-bit register as well as 64-bit memory.
So means 4-bit. There are 64 block like that. Means
Register
1
0,
4-bit, 1
3
4-bit,
means
4-bit.
there are 4-bit
It's 4-bit.
register. Yeah, register is capable of storing 4 bits of information, and memory 0 to 63. It is having 64 bit of the information. There are 64 location, in fact.
Means 64 multiplied by 4.
64 locations, and in each location you can give some data also.
Means it become 256 bit. We can say that, sir.
Means,
In
64,
allocate.
64, yeah, if I take 64 locations and each location is capable of storing 4 bits of information, so total number of bits will be 64 into 4.
Yeah, 256. Yes, sir.
Yeah.
Sir, my
Yeah,
question
please.
is very much similar to the above question asked by a student. Yes, sir. In the for RCA 4-bit addition, we will be doing no, sir. For ripple carry adder, the input which we give is 4 bits, sir. So should I mention it as 8?
If you have the screen sheet, screenshot you can share actually, because actually this videos I recorded last year, so I don't remember which circuit I have drawn actually.
Yes, sir. It is not about the circuit. It's a general question which I'm asking. Should I write it as A? Yes, sir. For ripple carry adder, should I write it as A 3:0 or I should write 3:0 A?
So normally MSB will be given first.
Should I write the vector specification before A or after A?
After A.
In the above example given by the student, if we are writing memory 0:63, it was showing 64 locations, no, sir?
Yeah.
But we want it as complete one vector, so it should be written before A.
So means there is some memory 0, memory 1, memory 2, so on up to memory 63.
Sir, actually, my doubt is not getting clarified, sir. I'm getting confused whether I should write 3:0 A or A 3:0.
That anyway I can write that.
Okay, sir.
Sir?
Yeah, please.
Sir, how to check the equality of 2-bit comparator using XOR and AND gates?
Equality. Equality is exclusion OR operation. If you apply these bits to exclusion OR gate, if both are same, output of the exclusion OR gate is 1. If you have 2 bits, 2 exclusion OR gates, one output you call as E0, other output you call as E1. If E1 into E0 is equal to 1, means both the bits are equal. A single bit equality detector is exclusion OR gate. If you want 2 bits, you have to use 2 exclusion OR gates. So like that, you can extend to any number of bits. If all the bits are 1, then only you can say that the 2 numbers are equal.
Okay, sir.
So there is one question: addition using 2's complement of minus 1011 and minus of 0101.
Yes, sir.
Okay. So this basically we have this both minus signs. So this is minus. If you take as common, this will be addition only. There are 2 ways actually. One is just this minus sign will be for subtraction, or you can represent this in the signed magnitude or signed 2's complement representation. In that case, there is no minus sign at all. If you want to add these two, if you take the minus as common, then it is simply addition, then we will be having minus sign.
Thank you, sir.
So 3 bit by 2 bit, if you take, say, for example, A2, A1, A0 into B1, B0. So for B0, we'll be having with A0, A1, A2, 3 AND gates. Similarly, for B1, 3 AND gates. 6 AND gates are enough. Why do we require 12 AND gates? 16 AND gates are not required, only 12 are enough. 3 bit by 2 bit, there are combinations will be, if I assume that the first number 3 bit number is A2, A1, A0, the second 2 bit number is B1, B0. Then A0, B0 with A2, A1, A0. So totally 3 product terms, 3 AND gates. Similarly with A1, 3 AND gates. 6 AND gates are enough. So that might be wrong. Actually, you can notify.
Sir, but in assignment, it is given that 16 AND gates.
Then it's wrong. Actually, I'll tell you the TS, they will correct. You just write in the discussion forum also that you inform to the TS. Actually, this my teaching assistants will take care about all those things. But 6 is correct answer.
Sure, sir. Thank you so much.
Okay. So is that fifth question is of a week 2 assignment is the same thing? I don't remember actually. Somebody asked about the fifth question of week 2 assignment.
Yes, correct, sir.
Yeah.
So see the chat, sir. I have posted one.
Yeah, I'm seeing.
Yeah, sir. For the register 03, and it is a memory of 64 bit, later 0 to 63. It will be in the memory. It will be allocated as so in the first way, or it is in the second way. Means
So
first.
They are combining two things. One is register 03, another is memory. So if it is register 03, then it will be the second one 0 to 64 or 0 to 3, whatever it may be, the number of bits will be. So this will be second one will be correct for the register, and first one will be correct for the memory.
Okay.
Anyhow, this and all in detail. So you will study in the coming lectures actually. There have discussed about the arrays also.
Okay, sir. Okay.
So demultiplexer, multiplexer is basically the way in which we are going to interpret the control signal and input. Okay, the circuit is same, but if we interchange this control signal and inputs, then we can convert multiplexer into demultiplexer and multiplexer into demultiplexer into multiplexer. So if you take the multiplexer, say for example, so multiplexer will be having 2 to the power of n inputs, n control signals, 1 output. Whereas demultiplexer will be reverse. That will be having one input, 2 raised to the power of n outputs and n control signals. In any case, control signal is same. If we exchange the number of inputs and number of outputs, you can obtain one from the other. If input is 1, outputs are 2 raised to the power of n, demultiplexer. If input are 2 raised to the power of n, output is 1, multiplexer. But number of control signals in any case is n only. Is my answer clear? No, they are combination circuits only. But they can be programmed in a similar way to the other combinational circuits. We have not covered all the combinational circuits. PLD, PROM, these are combinational circuits only, not sequential circuits. So the difference between the combinational sequential is in case of sequential circuit, it contains the flip-flops. Whereas programmable logic devices such as PROM, PAL, PLA, these things does not require any flip-flops. We can implement by using an array of AND gates followed by array of OR gates. So writing the Verilog code is simply, so we have array of AND gates, array of OR gates, okay, and we have interconnections that you can easily write by using gate level modeling.
Sir, the difference between a unary operator and the binary operator that I've sent.
So if you take A is equal to 4, B is equal to 3, then if you write in the binary form, it will be 1 0 0 0 1 1. End operation of that one will be 1 0 0 0 1 1. There is no overlap. Result is 0.
Okay.
And if it is binary, then you have to mention only single bit. So 4 and 3 are not allowed. So only it can be 0 or 1. 4 3 means this is a combination of 3 bits. 1 0 0. 3 is 0 1 1. So if I write unary operator A and B, so it will perform bit by bit. 1 0 0. You write down that 0 1 1. Bit by bit end operation will be no 2 bits will be 1. So that is why all the 3 bits will be 0 0 0. So result is 0. Result if you call y is equal to A and B, that will be 0. And if you want binary operation,
result is 0 in the binary case, sir. Binary operator.
Yeah, 0 0 0. In case of binary, actually you have to give binary values only. This 4 is not allowed. It can be 0 or 1 only. Only single bit.
Okay, sir.
So this is no need to draw the circuit, just only you have to exchange the inputs and outputs. In case of 1:2 demultiplexer, there will be one control signal, one input, two outputs. Whereas in case of 2:1 multiplexer, there is one control signal, two inputs, one output. If you change the number of inputs to the outputs and outputs to input, then you will get demultiplexer from the multiplexer. So we don't need any extra circuitry, we don't need any extra gates. So the only way is how you are going to interpret this circuit. So demultiplexer will be having, so if you have 1:2 means one input, two outputs, that number of outputs should be a power of 2, 2 raised to the power of 1. So the number of control signals are 1. Similarly, 2:1 also the number of control signal is 1 in any case. But in case of multiplexer, you have to give 2 inputs. If I give the control signal as 0, the first input will be transferred to the output. Control signal as 1, the second input will be transferred to the output. Whereas if you take the demultiplexer, if control signal is 0, whatever the input data, single data, that will be transferred to the first output. If control signal is 1, the input single data will be transferred to the second output. So it's unlike this, realizing this 4:1 multiplexer by 2:1 multiplexer, that type of relation is not required here. Both our circuits are same, only we have to exchange this input and the outputs. Control signal remains same. Yeah, unary operation will be performed only on the single bit numbers only. If it is more than 1 bit, then you have to apply the unary operation will be on the number of bit can be or more. You can perform unary operation, but binary will be only single bit. Unary you can operate on the single bit also. If A is equal to 1, B is equal to 1, if I write Y is equal to A and B, then it will be 1. If A is 1, 0, B is 0, 1, if I write Y is equal to A and B, output is 0. Which operation is this?
Star, sir.
Star, 2 stars.
Yes, sir.
There is no such stars operation.
Yes, sir, there is one, sir. It means, sir, if we write to a star to a star 3, it means, sir, 2 to the power 3, sir. Exponential one, sir.
Exponent, sir.
Yeah, yes.
Yeah, that actually I didn't cover in this course, because floating point numbers, that deals with the floating point numbers and all. So this is actually, as I have told in the introduction class itself, this is basic level course, especially designed for the undergraduate students.
Okay, sir.
Yeah, latch is without any clock signal. Flip-flop is having a clock signal. If you connect 2 NAND gates,
excuse
back to
me,
back,
sir.
Yeah. Please ask.
Sir, I'm a bit confusing regarding test bench, sir.
Regarding?
Test bench, sir.
Test bench. Test bench actually I have discussed in the coming lectures actually. Initially, I taught about all the 3 types of modelings. Then the last, nearly some 6 to 7 lectures, all will be test benches programs only.
Okay, sir.
So at the end,
sir,
you will understand about test benches.
Sir, how to synthesis in tool, sir? I'm not getting, sir.
Synthesis, you can use this either FPGA or Asic. You can write FPGA, if you have FPGA software, then you can synthesize the program. You write the program and you just synthesize. There is a synthesis tools are there, ISC and all.
Sir, I have a tool, sir, QuestaSim, like QuestaSim, sir. But how to use, I'm not getting, sir.
So there will be option. If you go, there will be option like synthesize. Run the program. You can run the program.
We can see the waveform, sir.
Yeah, you can see the waveforms. Actually, in the last lectures. So you can watch my last lectures. There I have shown the waveforms also.
Yeah, okay, sir. Okay, sir.
Yeah. So the basic difference between the ASIC and FPGA is FPGA is a general purpose. Actually, we will be having all libraries. Say multiplier, adder, all those things will be libraries. In ASIC, actually we have to design your own multiplier, you design your own adder, every block you design on your own. Because of that, ASIC is more optimized. Whereas in FPGA, we can take all the blocks from the library and you can just interconnect those things. Okay? So whereas in ASIC, like in case of mobile phones and all, so if you have a specific application, say FFT, I want a IC for the FFT. So you take the FFT block diagram and you require some multiplications, additions. So you develop your own multiplier, you develop your own adder, then you interconnect and you fabricate on an IC, that will be ASIC. Whereas FPGA is a simulation platform where you can verify whether your design is correct or not. Once if you verify using the FPGA that your design is correct, then you draw the ASIC correspond to that one, you develop ASIC and you fabricate that onto the IC. ASIC will be in IC form finally, and FPGA will be something like you have to verify your functionality of the circuit. So you can, once if it is working properly, then you develop your own multipliers or adders, everything, all blocks, and then you fabricate it. That will be ASIC.
Sir, parallel prefix or adder?
Parallel prefix adder.
Okay, yes, sir.
So what is the software for Verilog coding?
Yeah, sir.
So we have this Xilinx software is there. Then Xilinx ASI is there, model sim. And there are some freely available Verilog simulators also there. You can search in the Google. You will get there are some free Verilog simulators. You just search for the Verilog simulator. So whatever the code that you are going to write, that will give the waveforms also. Test bench also.
Sir, please explain about parallel prefix adder, sir.
Parallel prefix adder. So parallel prefix adder is actually very rarely used. The adders are like carry save adder, carry look ahead adder. Parallel prefix adder, I don't find any application of that one.
Okay, sir.
Yeah, it's just functional verification we can do using the FPGA. Whereas once this functionality is correct, then we can fabricate that circuit diagram onto the IC. That is called ASIC, application specific integrated circuits. In mobiles and all, we will be having ASIC circuits only. FPGA means we need a big kit and all. Okay, ASIC means a small chip. Like you can verify this code if you write in the MATLAB, you can verify using the MATLAB also. So such type of thing is FPGA. In MATLAB, normally you will write the MATLAB code, whereas FPGA we can write the Verilog code and you can verify. Once the functionality is correct, then you go for the fabrication. That fabricated IC is in the form of ASIC, application specific integrated circuit. No, they are different. So ASIC design flow is much more complicated than FPGA design flow. Whether I have discussed this in this or no, not, I don't know. But these two design flows are different. ASIC design flow, I think I remember that I have discussed in the lecture, one of the lectures. In ASIC design flow, we'll start with the specifications, then algorithm, architecture, then we have gate level, then device level, transistor level, then finally layout. You have to optimize the problem at each and every level. Whereas in FPGA, we can take the many functions from the library.
Sir, layout means what, sir?
Layout is actually the connections between the various components. That layout, if you go to the foundry, then they will fabricate the IC. Suppose the output of an AND gate is connected to the input of another OR gate. Okay. So that AND and OR gates will be given in terms of metallic contacts only. In the final layout, we can see only the metallic contact. There is no circuit at all. Only metallic contacts will be there. So that metallic contacts, like if we take 2 input NAND gate, CMOS NAND gate, which I have discussed in one of the lectures, I think whether it is covered or not. There we'll just give the metallic contacts only. So if you have this Verilog course, sorry, we're not Verilog course, it's VLSI, Introduction to VLSI design. There we will be studying about the layouts. Because layout is not related to this course, that is I have not mentioned, but in many of these VLSI books, we can find the layout of a given circuit diagram. 2 input NAND gate layout is given. You can refer any book like Rafi or any book on digital IC design. You can find the layout. Layout will be in the form of metallic contacts. That if you go to the foundry, they will fabricate the IC.
Sir?
Yeah.
Sir, there will be a ring counter, sir. F by 3, we have to convert it for F by 3. What does it mean, sir?
So F by 3 means frequency, input frequency, clock frequency is F. Then the output clock frequency should be F by 3. So for that, you have to take 3 D flip-flops. If you connect in the ring direction, is the output of the last flip-flop, if you connect to the input of the first one. Then if you take the final frequency of the last output, last flip-flop, then that frequency will be 1 by 3 of that of this one.
Okay. That at 3 will rise to 1, sir.
No, it's actually if you have number of flip-flops is nothing but the division factor. This in general is called divide by n circuit. In divide by n circuit, n flip-flops will be connected cache to cache, back to back. All the D flip-flops. So the input clock is connected to the uppermost, this lowermost the flip-flop. Output of the lowermost is connected to the input of the next bit, so that it will continue. And the output of the last flip-flop will be connected as the input for the first flip-flop. That is why it's called ring.
Sir. Okay, sir.
So if you connect in that manner, if you have n flip-flops, if input frequency is F, the output frequency will be F by n.
Okay, sir. Thank you, sir.
There is no direct formula actually. If you want, you can derive the direct formula also. But by just looking into that number of bits and all, you can easily find out the number of AND gates required. And gates also actually the AND gates, if you take the 2 input AND gates, so the number of XOR gates and gates that depends upon the number of bits in the comparator. There is no direct formula between the number of bits and the number of XOR gates and AND gates. But in case of ripple carrier adder, there is a formula, but comparator there is no formula.
Sir, please explain blocking and non-blocking.
So in the blocking, what happens is, so they will execute in the sequence. The first statement will be executed first, the next second one, third one. By skipping the first, 2, I cannot go directly to the third one. They will execute in the sequence. Whereas in case of non-blocking, as the name implies, so like whatever you written, B is equal to A, C is equal to B, D is equal to C, all the 3 will be executed simultaneously. Whereas in case of blocking, as the name implies, it will block. So if first you execute the first statement, then only you can go to the second statement. Then you can go to the third statement. Okay? We cannot skip any statements. Whereas here, all the 3 initializations, whatever this the assignment that you have written here, all the 3 will be simultaneously executed in case of non-blocking. This is some sort of the parallel processing. You can call the non-blocking as parallel processing, whereas blocking is the serial processing.
Okay, sir. Sir, another which book we can refer, sir, for more information?
So even if in direct any digital books like Maurice Mano, Digital Logic Design, that normally you'll study for the digital logic design. So in that also they have discussed the logic design as well as the Verilog code also.
Yes,
not
sir.
all edition. There is one edition of Maurice Mano where he has discussed very clearly about all the Verilog programs also.
Yes, sir. Samir Paletkar.
Samir Paletkar is exclusively for Verilog.
Okay.
So at initial stages, I recommend this type of Maurice Mano and all because they have given in a simple manner.
Okay, sir.
No, within a block we cannot have both.
Sir, in bidirectional switches, can we use instances compulsorily or it might be neglected, sir?
Instances. It's not compulsory.
Sir, without instantiation, we can use the another syntax like x is equal to y is greater than 5 question mark and w.
But simpler way is instantiating. Actually, instantiating is something like subroutines, calling the subroutines in the C program and C++. Sometimes, actually, most of the times, instantiating will give less complexity to the code. Otherwise, you can write the complete code also. If it is a single, if you are able to write this in a single code like that multiplexer operation question mark by comma a comma b. So depends upon your simplicity. But most of the times, this instantiation will give less complexity to your code, overall code.
Okay, sir. Sir, why C is not used for hardware designing, sir?
Actually, C you can write design. There are some C using Verilog also there. But C, if you write to program the C and if you convert into Verilog code, then it will not give the optimized one. So not only in this Verilog, you can take the DSP processors also. In DSP processor, there is a assembly line, but you can write the code in C also. So there are, in almost all the cases, you can write the program using C, but that is not a optimized one. If I know that particular language, say Verilog or the assembly language of the DSP, then I can write the optimized code. But the C is actually the machine learning that it will convert into the code, but it will not optimized code. So the conversion from the C to any other code that will not give optimized code. Optimized code is possible only if I write using that particular Verilog or that assembly language. But
Okay,
for the complex systems, if it becomes difficult to write the code, then you can use the C.
Okay, sir.
No, in the exam actually I don't write. Ask any test benches and all. That is only for the explanation. So in exams and all, actually it will be something like all multiple choice questions only. So even if it is test benches also, you'll be given some test bench and based on that you'll be asked some questions. But no need to remember the test benches. Question paper will be all multiple choice questions only. There are some, I think, 1 mark questions. There are some 2 marks questions, or sometimes I'll give a big program. So I'll ask the questions like after execution of this program, what will be the variable value, say some A, B. So like that, you'll be given a code. No need to even remember the codes also. Okay. So sometimes I'll give you the code and I'll ask the question. Sometimes I'll give a code where I'll miss 1 or 2 syntax or 1 or 2 statements. Then you have to write what is the missed statement and all.
Sir, in course, have you done about UDP concept as well as the switch level concept, sir?
Switch level I have covered, no? Switch level I think covered. Switch level in terms of CMOS gates. And UDP also, test benches are covered at the end of this course.
Sir, in other languages, in other programs, we write addition of 2 numbers, subtraction like that, sir. In Verilog, we can write, sir.
Yeah, actually in Verilog there are 3 types of modeling, as I have told. Behavioral is there. One is gate level, and another is data flow. So in case of gate level, you have to design the circuit, and finally you have to draw the gate level circuit using AND gate, OR gates, NOT gates, and all. That is more optimized one. Gate level is always more optimized one. Whereas A plus B, you can directly write A plus B for addition. So in case of behavioral model and data flow model, you can directly write A plus B. But how that A plus B operation will perform, that depends upon the inside the circuit. So that may not give the optimized result in terms of the power, area, and speed. But there is that you can write directly Y is equal to A plus B.
Okay, sir.
FSM, actually directly FSM, in terms of FSM I have not covered, but in sequential circuit design I have discussed about the procedure in terms of the state diagrams. State diagram, state table, the design of sequential circuits using the state table I have discussed.
Sir, differentiate, how to differentiate task and function, sir?
Task and function. Can you repeat the question?
How to differentiate task and function, sir?
Task is actually that a connection of the functions. A task may contain more than one function also. Function is like, say, OR operation is also function. AND operation is a function. Task is, say, a full adder. Full adder requires one exclusive OR gate, one AND gate. Okay, so that will be task. Task consisting of one exclusive OR operation and operation. Whereas function is one exclusive OR is one function and AND is another function. Yeah, 1:2:1 multiplexer only. Both the circuits are same. Only the difference is just you exchange the number of inputs and outputs. You connect the input to the output. You make that output single output as a single input. In case of demultiplexer, 2 inputs you take to the output. So in the circuit also, if we take the circuit diagram also, the way in which where we are going to apply the inputs from where you are going to take the outputs, that will change the operation. If I have the circuit diagram of 2:1 multiplexer or 1:2 demultiplexer using the gates. So it depends upon where you are going to apply the inputs, from where you are going to take the outputs. So based on that, the same circuit will act as multiplexer as well as demultiplexer.
Sir, please in next upcoming videos, one Verilog code you can synthesize and show to us, sir, so that we can we will synthesize other programs.
Since I think I have shown in the last lectures. So last lectures actually I have shown many programs. I have given the synthesis results also in terms of the waveforms.
Procedures.
Procedure. I'll see actually I have to again record that lecture, because this I have recorded last year actually. So if anything is to be added, I have to know what is the procedure and all.
Okay, sir.
I think the time is over. Next, I think there is one more live session of the other course, I think. So if you have any other questions also, you can ask in the offline also. You have my mail ID and all. Anyhow, there will be one more live session probably in the next month. That time also you can ask, even you can ask offline also. In discussion forum also you can ask. Okay, then thank you. Thank you for your participation.
Thank you, sir.
Thank you.